So, to start off, I'd like to say that my name is Quest Mullins, and this is my negative rebuttal. So, first off, my opponent mentions that solar panels, um, they are too expensive. You need to own a house to actually have a solar panel. But I'd like to say that, first off, solar panels are not only for house owners, but they're sold on many websites. Small personal ones, for example, you can use them in your cars. Students can use them. Small businesses can use them if they want to get some extra power. Also, you can put them on trailers, camping supplies. It's basically, you're making it so you're self-sustaining without needing to bring batteries or gasoline in order to power whatever you need to power outside of regular civilization. So solar panels are they're very accessible and very easy to find if you look them up. Also, she says that helium-3 will not run out, but on the contrary, in an article by Tim Singh on January 28th, 2015 on Inhabitat.com, he states that helium-3 will last approximately 10,000 years. And yes, I understand that's a long time. But also, you need to know that helium-3 is extracted. It's not in piles. It is extracted in a rigorous process in which the regolith, which is the moon soil, is heated up to approximately 700 degrees Celsius, which is much hotter than 700 degrees Fahrenheit. And this means that in order to create machines that can do that on the moon, we'll have to put in more resources from Earth that we need for our own development, and we'll have to be putting them into the moon where we aren't. Now, also, you say that helium-3, or okay, so you say that, my opponent says that helium-3 can be used for an infinite amount of time. She doesn't exactly state, she just states that it won't run out. And like I said, it only lasts about 10,000 years. But granted, that's a long time. We also do face another issue. In an article written by Gregory Bennett on August 16, 2014 on newenergy.org, that's nuenergy.org, he states that helium-3 may be used just the same as a fossil fuel, and basically that means that helium-3 is going to be used as a fossil fuel, and that will put off creating self-sustaining energy. So basically, by using helium-3, we're putting ourselves in a deeper hole by just postponing the inevitable. So I feel that it is very important to start developing self-sustainable energy, such as greater solar panel energies or hydro energy, in order to prevent this inevitable outcome. Now, also, there we go. My opponent also states that helium-3 is not dangerous due to the fact that it is not radioactive. And yes, I do agree. It is not radioactive. It only gives off a hydrogen particle and one proton. But one thing that is very important, and the reason why we really should not go down that path of starting up nuclear fusion, is because that helium-3 can be a danger to surrounding wildlife due to the fact that the energy needed to create nuclear fusion is equivalent to the environment of a star, that being it is just as hot and has just as much pressure, which could result in using as much energy as we create. And just to start the fusion cycle and just to continue it. So what you're saying here is that you're seeing a environment that, if broken, could devastate entire neighborhoods almost, just because you have this insane heat equivalent to the sun and the same pressure equivalent to the sun, which is many millions times larger than the Earth. You're creating that same environment on the surface of our planet. So if that energy got released, if anything was damaged, then we would see resulting catastrophe. Also, Imagine how much money it must take to reinforce that bunker and that whole fusion generator in order to protect the outside from any leaks or damages. And also, with all that heat, we're going to be needing to cool a lot of that as well. So you're going to see a lot more global warming issues in the ocean, because how nuclear reactors work is that they will take in water to cool down the nuclear liquid, and then that water gets sent back out. So what you're doing is you're taking all the cooled water, you're taking all the cold water that the sea life knows how to live in and has adapted to. You're heating it up, and then you're killing that sea life. And so by heating up the water even more than our nuclear fission reactors, you're killing more ocean life. So overall, just very dangerous to be doing. Now, lastly, rocket travel is very damaging to our environment. That being, there's a substance called black carbon that is generated each time a rocket is sent off. It's a combination of hydrocarbons that absorb a lot of heat, and particles absorbing heat is the main cause of global warming. So, by continuing rocket travel to the moon, we continually damage the ozone layer. And this article was written by Martin Ross on July 1st, 2011, on aerospace.org. Traveling out of the Earth via rocket creates soot layers that can extend around 25 miles within the stratosphere, which also leads to global warming. In the end, traveling to the moon is not only more taskly, but we are using around 4 million gallons of fuel, depending on the size of the rocket, to get there. But traveling to the moon will be a way to ignore the larger issue, that being that we are postponing self-sustaining energy, and if we continue to ignore these issues, they will just get worse and worse, and then eventually we'll have to face them, and we won't be able to come back from it. We're just going to be at a dead spot. So overall, I feel that we should focus our resources on developing renewable energy.